right, we're going to look at 12.7 notes today. First, I actually want to start in Desmos. So if you go to our class, in classwork, you'll see this inverse trig graphs, and you follow it to a Desmos link. And you can select equations and unselect equations. You can also adjust the equations that I have done for you if you want to do that. Okay, so if we talk about the sine function, okay, this is a function. It fits the definition of a function. Okay, for every x, there's exactly one y. Another way you can tell if a graph is a function if you do the vertical line test. If each vertical line you can draw only intersects the graph once, you have a function. Now, the inverse of this function would be the reciprocal, would be the reflection over this y equals x line. Here's the y equal x line. So I don't know if you can kind of visually, if you would flip that sign, you would have a squiggle, kind of a vertical squiggle, and it would go back and forth. Well, now it doesn't pass the function test because if you do a vertical line, you're going to hit multiple points. Okay, so this sine function does not in and of itself have an inverse. However, if we restrict the domain of the sine function, okay, which is this blue one I just turned on, okay, you can see that it goes from negative pi over 2 to positive pi over 2. So if we only look at that portion and not the entire sine function, now if we reflect this over the y equals x line, you get this inverse function, and that's the green one. I'll take that one out of the way. So if you reflect the blue one, you get the green one. So this green one is the inverse sine function. You'll also see it written as arc sine, and I'll show you what it's the same notation. Literally, it says arc sine, and that means the same thing. Okay, you can also do this with a cosine function. So here's your cosine function. Again, if I try to reflect this over the x equals y line, it will not be a function, so therefore we're going to restrict the domain. When you restrict the domain on cosine, we restrict it from 0 to pi. And then if you do your y equals x line, the inverse cosine will look like this. You can zoom out a little bit if you want to. If I get rid of that y equals x line, there's the cosine, and then it's inverse. Okay, similarly, you can do the same for tangent. Here's your tangent. But again, if we reflect that over the y equals x line, it's no longer a function, so we're going to restrict the domain. And tangent is restricted from negative pi over 2 to positive pi over 2. And then, oops, didn't mean to do that, but apparently I forgot to type in. So y equals, okay, I'm going to just type in tangent. I think I can just go caret -1 x, and there is your inverse tangent. Okay. All right, so I wanted to show you those. Now, one thing we're going to be paying attention to today as we go through our notes is where our domains are restricted for these inverse cosine, sine, and tangent functions. Okay, so this is in your notes. You're going to have access to that. You can always come back to that link, look at your graphs again if you want to see those. And right now we're going to go to our notes. Okay, so a couple of things to pay attention to. You're going to need to know that inverse sine or arc sine is limited to negative pi over 2 to positive pi over 2. Think about your unit circle. If you go negative pi over 2 to positive pi over 2, that puts you in quadrants 1 and 4. Okay, so the inverse sine is defined in quadrants 1 and 4. So example 1 here, find the arc sine of -1/2. So if we think about quadrants 1 and 4, a couple of things we can do is we can think about where the sign is negative. So all snow tastes cold. So quadrant 1, quadrant 4, the arc sine or sign is negative in quadrant 4. Okay, so we'll be looking in quadrant 4. I pulled up a picture of a unit circle. Hopefully you should still have your own unit circle. But if I'm looking for the arc sine, I'm looking for an angle measure whose sine is a -1/2. Well, if you remember, the sine of an angle measure on the unit circle is the y value. So in the fourth quadrant, the y value that is -1/2 is at 330 degrees. Or we have been working in radians. Hang on here. I had a unit circle for my radians. Maybe I'm scrolling the wrong way. Well, rats. I'm not seeing it. There it is. There it is. Found it. Okay. So 330 degrees, or that's the same as 11 pi over 6. So theta is going to be 11 pi over 6. However, remember back here, arc sine is defined for negative pi over 2 to positive pi over 2. 11 pi over 6 is not in that domain. So we need a coterminal, another angle that gives us that same angle measure but with a different name. So a coterminal will do that, and a negative pi over 6 would be have the same terminal side as 11 pi over 6. And this angle measure is now within that range. Okay, so the next one, find the inverse sine of √3/2. Well, okay, so this time my sign is positive. So if I'm choosing between quadrant 1 and quadrant 4, I'm in quadrant 1. So look at quadrant 1. You're looking for a y value that is a √3/2. And that's going to happen at pi over 3. So this is pi over 3. Okay. Now, cosine, as we saw with the graph, is defined for angles from 0 to pi, which means that arc cosine or inverse cosine is going to be in quadrants 1 or 2. Arc tangent is defined for negative pi over 2 to pi over 2, same thing as sine. And so you are looking at quadrants 1 and 4. Okay, so arc cosine. So you're looking in quadrants 1 and 2. Again, you can think about which quadrant gives you a positive angle measure. So all snow tastes cold. If you're looking quadrant 1 and quadrant 2, then quadrant 1 is where cosine is positive. Also, remember, cosine of theta is the x coordinate on your unit circle. So look in the first quadrant. I'm looking for an x that is √3/2, and it is pi over 6. Okay, number 4, tangent, inverse tangent of -1. So what angle measure gives you a tangent of -1? Okay, think about tangent is defined for quadrants 1 and 4. All snow tastes cold. So tangent is negative. We are looking in the fourth quadrant. So in the fourth quadrant, tangent, unit circle, tangent of theta is y divided by x. So in the fourth quadrant, if you would take the ordered pair negative √2/2 divided by √2/2, that would give you -1. And that angle measure is a 7 pi over 4. However, okay, tangent is defined from negative pi over 2 to positive pi over 2. 7 pi over 4 does not fall in that category. So I need to come up with a coterminal angle, and that would be the same as a negative pi over 4. Okay, calculator. On your calculator, you can also find the angle measures. So if you just turn on your calculator, then most likely you are going to be in radian mode. Okay, so if I go tangent, not tangent, inverse tangent. So go second tangent of negative 8.45 equals negative 1.45 approximately. Now this is in radian measure. Okay, now if you just leave it negative 1.45, I'm going to assume that you are talking about radians. Okay, however, I didn't specify if I wanted you to do radians or degrees, so it's your choice. You can give me either one. If we go back to mode, we can change our radians to degrees. And if we do the same thing, we go second tangent of negative 8.45. Oops. There we go. And hit enter. You now get negative 83.25, and that's degrees. Okay, so we changed our mode to degrees, and this is now a degree measure. Okay, and you're going to tell me it's degrees by using the degree symbol. Okay, if there's no degree symbol, then that means you're telling me radians. Okay, all right, example 6, same thing. We can go inverse sine of 0.2447, and we get 14.16. Now again, we're in degrees, so give me a notation for degrees. If you do this in radians, then you will have 0.247. And if you just leave it 0.247, that tells me radians. Okay, example 7, inverse cosine of negative 2, and you get an error message. Okay, well, what's happening? It's undefined. Actually, I should put undefined. Think about your cosine graph. When you graph cosine, it oscillates between +1 and -1. It never goes above +1 or below -1. And actually, when I typed that in, I did inverse cosine of -2. It should have been inverse cosine of 2, but the same thing's going to happen, whether it's +2 or -2. It's outside of that domain, so it's undefined. Okay. All right. Number 8, A and B. Okay, let's go back just a little bit. If I give you a triangle, label this and say, here's theta. This side is 2. This side is, we'll just say 4. Find the angle for theta. What's the measure of that angle? Okay, well, you would set up a trig equation. So 2, this is your opposite side. This is your adjacent side. Okay, so opposite and adjacent is tangent. So you may say, okay, so tangent of theta is 2/4. And so if I want to find that angle measure, I'm going to do the inverse of 2/4, and then that will tell me the value of theta. Okay, example 8 is the same thing. You just have 2 variables instead of 1 variable. Okay, so go from theta. This would be the adjacent side. Okay, I'm not drawing. What did I hit? Okay, so for 8A, this would be the adjacent side. This would be the hypotenuse. So to make